What's up, pre-calc? We are going on and on and on with these triangles here. So we got a last couple things here. This is the last part, I promise. Okay, we're going to deal with the area triangles, but we're actually looking for the area of a segment. So that happens when we inscribe a triangle inside of a circle, like we got here. Notice we're working off the center, the radius, all this stuff is happening. And the piece that we're after, just like my pizza over here, we're after the crust. Okay, so that's what we're talking about today is the segment of a circle. All right, so we got two different formulas. If it's in degrees, all right, we're going to find the in degrees. That was a pretty big degree sign. Looks like a big old zero. Okay, so the measurement in degrees divided by 360 times pi r squared. And that's going to work on the step number one, right? So we have step number one, and then we're going to find the area of the triangle. Okay, so that's going to give us the whole thing. And then what we have to do is subtract. Okay, so no easy peasy way to do that. When we talk about radians, our calculator has to be in radians. So I get that under here somewhere. Okay, so I hit the mode button right here and notice this fourth line down between radians and degrees, right? So this is how we flip-flop these guys back and forth, right? So I hit enter, it changes it. I'm like, no, I want to be in degrees. I hit enter, it changes it, right? If you're dealing with the smaller TI calculator, okay, along the top here, you're going to see the second button in says degree on it. When I hit that, I get the option to change it over. Okay, so that's your quick reminder so you don't have to Google it unless you really want to. All right, now there's a chance that you never actually need the radians formula. It depends on which one you like by the time you do this a couple times. Is you can always change it into degrees. So if you just want to go through one process, you can stick to just degrees and work with it. This pizza is making me really hungry up there. Oh man. All right. So let's figure out how it works. So we got our formulas, right? So I do want to work in this order, so I can do it that way. So let me grab my paper here so I have all the numbers in order to go with it. All right. Find the area of a circular segment inscribed in a circle with a radius. Okay. So here's something I need, and an angle of 50 degrees. All right. So let's just go in order here. So first thing we're going to do is we're going to find 50 divided by 360. We also know that it's pi times 15 squared. All right, so we're going to drive all that in the calculator. Remember, we have to do my exponent before I can multiply. And if you put it in correctly, we have 98.17. 98.17. This is so far units squared. All right, but that was step one. So I'm going to label these as step one. Step two. Okay, now I'm going to find the area of the triangle. So my area of the triangle, I got 1/2. I got a side times a side. Well, guess what? The sides are radius 15. So I need 15 squared. And we want to be times the sine, right? Remember, I am in degree mode here, sine of 50. All right, so personally, I like to do sine of 50, get that answer. We're going to do it times 15 squared times 1/2 or 0.5 makes it a little bit easier. If you got 86.18 units squared, okay, so that's the triangle. And then the last thing we're going to do is we're going to take and subtract it. Okay, so we started with 98.17. We're going to subtract 86.18. And that should get us 11.99. It rounds a little bit more. So what I'm going to do is I'm going to call it 12 units squared. Okay, so that means the crust, right? So the crust is talking about an area of 12 units squared as we look at that from a 50-degree angle. All right, the next one is in radians. Oh man, how do I know it's in radians? There's no degree sign. Remember that from dealing with those? Okay, so what we'll do is we're gonna work with this. So remember, you gotta change your calculator over. You wanna put yourself in radians so we can work through it. So how's this one work? We're gonna do 1/2. We're gonna do the radius. What was the radius? 6 squared. And then what we need is 2 pi over 5 minus the sine of 2 pi over 5, right? So that's what these are in here. They're not really A's, they're thetas for angle measurements here. So we'll put these in here. So in degree mode, or I'm sorry, in radian mode. All right, so this is going to be 6 squared is 36. Half of that is 18. So I'm going to give you a number in between here. if I do 2 pi divided by 5 minus sine of 2 pi divided by 5, then we're going to end up with 0.3055, and we're going to multiply those together to get about 5.5 units squared. Okay, so the upside of using that formula, we are done. Downside is we had to go into radians, we had to do all this other stuff. So how would I do it? If I'm like, you know what, there's no room in my brain for this other formula. I don't want to look it up. I feel like I know what I'm doing with the other one because it was kind of okay. So remember, 2 pi over 5 equals 180 over pi. So I'm sorry, that equals, we're going to multiply. So that means we're talking about 72 degrees. So I could work through all the steps that I did up here in the first example. So I can do 72 divided by 360. This is a good way to check as well. We're talking about pi 6 squared. So we'll get all this stuff together. And I had that written down here. Where is it? 22.619. Okay, so we had kind of, that's step 1. So this is like step 0. I don't know what to call it. Now it looks like a donut. So the next thing we're going to do is follow our second one. So the area is 1/2. All right, this time we're going to use 6 squared. And we're going to use sine of 72 because that's what we found that whole thing to be. All right, and that one's going to come out to, right, sine of 72 times 36, take half of that. So we got 17.11. Right, and then my step 3 is to subtract those. So 22.619 minus 17.11. And guess what it gets us? 5.5 units squared. So if you're ever not sure, you forget like, oh, wait, is that all I have to do if it's in radians? Then we can do that. For all intents and purposes, if you really like radians, then you could transfer all your degrees into radians and always use the radian formula. I don't know why you would do that. The formula, it only has one step to it, but it's totally up to you. So that's the last thing we have to do with our circles and triangles here. We get a little homework under here. If you think you're good, then I believe we're doing top is evens, and the bottom we're going to do all 4 of these. Okay, so that gives us just a few here. Use the space all around the notebook. If you're not in my class, you're like, I'm not doing your homework, and that's fine too. All right, peace.